Assalamualaikum warahmatullahi wabarakatuh. Hey guys, so today I wanna share and present my presentation based on my projects. So before we start, let me introduce myself. My name is Auliazqi Rarasati Najid with the student number 204222116. I'm from Instrumentation Engineering Department, Institut Teknologi Sepuluh Nopember. So, the rapid advancement of technology has significantly enhanced human activities, enabling innovative solutions across various sectors, including ornamental fish farming. Goldfish, or Carassius auratus, known for their vibrant colors and unique shapes, are a popular choice for aquariums and ponds. However, maintaining optimal water quality is a critical challenge for breeders as poor conditions can lead to health issues and financial losses.
What is the problems? The problem statement is how can an automated monitoring and control system for water pH and temperature improve the success of fish farming? How can IoT technology, specifically the Blink application via Wi-Fi, simplify remote monitoring for breeders? What water quality parameters are essential to maintaining the health of goldfish? So the scope of study is focuses on water quality parameters and utilizes the Blink application as the interface and ASP32 microcontroller for data processing with Wi-Fi connectivity and testing conducted in a laboratory scale or small pond setting. The objective of my projects is develop a real-time automated system for monitoring and controlling water pH and temperature. Leverage IoT with the Blink app for easy remote monitoring and enhance goldfish farming management using integrated sensors and actuators. The benefits of my project is can provide a technological solution to maintain optimal water quality, enable online water quality monitoring, minimizes loss from unmonitored water chains, ensures stable and efficient aquaculture conditions. The literature that I use is at 2021. There are literature. The title is IoT-based aquaculture monitoring by John. Utilizes IoT sensor like pH, temperature, DO with ASP32 for real-time monitoring. The result is 30% increase in operational efficiency through accurate data collection. And then the second literature is Smart Aquaculture System for Fish by Ahmad. Integrated clean app and sensors for freshwater fish farming can achieve a 95% survival rate with early warning for unsafe water parameters. And the third, fourth, fifth literature can you see at my task.
Based on the problem, I make these innovations. The title is Water Quality and Acidity Monitoring System for Optimizing Carassius Auratus Cultivation based on Internet of Things or IoT. This IoT-based water quality and acidity monitoring system offers a comprehensive solution for goldfish farming by integrating advanced sensors and intelligent actuators. The system employs 5 sensors and 5 actuators for automated control. Its IoT connectivity enables remote monitoring and management via a user-friendly interface, reducing manual efforts and human error. The system improves fish health, reduces mortality, and boosts productivity, making it a scalable and efficient choice for modern aquaculture needs. So, what is the Internet of Things? The Internet of Things, or IoT, enable objects to transmit data via a network. As shown in figure below, sensor data is collected and sent over the Internet, where it is processed and presented for user interpretation. The component of Internet of Things is network, device, and platform. The network is internet connection enable device communication. The second one is device. The description is physical object with sensors, actuators, and microcontrollers. And the platform is cloud services managing IoT devices, data, and apps. Okay, like I mentioned before, I use 5 sensor and 5 actuators. The first sensor that I use is PHA201C sensor, salinity sensor, module DO sensor, DS80P20 temperature sensor, and ORP sensor. Okay, the PHA201C sensor is measure the water acidity or alkalinity to ensure it stays within a safe range for fish. The set point should be between 6.5 and 8.5. And then the second sensor is salinity sensor. Salinity sensor measure the salt concentration in water to ensure it is suitable for goldfish cultivation. The set point should be between 0.2% and 0.5%. The third sensor that I use is DO sensor. The DO sensor can monitor oxygen levels in the water to ensure fish have adequate oxygen for survival. The set point is should be greater than 4 milligram per liter. The fourth sensor that I use is temperature sensor. Temperature sensor can track water temperature and the set point should stay between 22 derajat Celsius and 28 derajat Celsius. Next, the last sensor that I use is ORP sensor. ORP sensor can measure the oxidation reduction and the set point it should be between 2000 millivolt and 1400 millivolt. Okay, next slide. So the actuators. The first actuators that I use is relay module for channels. It can control devices and the set point is such as pH under 6.5 or up to 8.5 or the temperature up to 28 derajat Celsius. And the second one is exhaust fan. Exhaust fan can control air circulation to regulate water temperature and oxygen levels. The set points is exhaust fan can activate when water temperature exceeds 28 derajat Celsius to help cooling the environment. Solenoid valve. Solenoid valve regulates the flow of water or chemicals like acid or base to adjust pH level in the system. And it can be activated if pH is outside the 7 until 8 range and adding acid or base to correct the pH. There is indicator lamp, provides a visual indication of system status like green for normal operation and for abnormal conditions. And it activates like lights operate if temperature exceeds 28 derajat Celsius or pH is outside the optimal range. There is buzzer too, like sound an alarm to alert user of abnormal condition that may harm fish health. So the set point is up to 28 derajat Celsius or under 7 pH or up to 8. There is motor GC, can controls mechanical movements such as adjusting valves, rotating mechanism, or driving aeration system. It can also regulate water flow in certain applications, and it can activate or turning on when a pump or valve needs to adjust flow to maintain optimal temperature. Here the flow chart. The first is start. The system begins by reading data from various sensors used to monitor the water quality in the Carassius Auratus fish pond. And then the second step is checking the pH, salinity, pO, temperature, and ORP. After the data is down to read, the system checks if the values of each parameter like pH, salinity, dissolved oxygen, temperature, and ORP are within the optimal range. It can be two options, like if the values are within range, the system proceeds to the next step. And if any value is outside the range, the system activates the appropriate actuator to adjust the parameter. And the next step is checking the pH. If the pH level is outside the desired set point, the solenoid valve will be activated to adjust the pH level by adding or reducing pH regulating. And if the pH level is within the range, the system proceeds to check the salinity. Okay, next, to check salinity. If the salinity is too low or too high, the fan or the actuator will be activated to increase air circulation or saline water may be added to adjust the salinity levels. And if the salinity is within the range, the system proceeds to check dissolved oxygen levels. Next step is check dissolved oxygen or DO. If the dissolved oxygen level is below the optimal level, the solenoid valve or aeration system will be activated to increase oxygen levels in the water. If the oxygen level is adequate, the system proceeds to check the temperature. Next step is check the temperature. If the water temperature is too high or too low, the indicator lamp will be turned on as a warning, or the fan will be activated to reduce the water temperature. And if the temperature is within the range, the system proceeds to check ORP levels. Next step is check ORP. If the ORP value is not within the ideal range, the system will activate other actuators or provide an alert to operator. If the ORP is within the range, the system proceeds to log data. Okay, the next step is to log data and update IoT. After all sensors have been checked and the necessary actuators have been activated, the system logs all the collected data and send updates to an IoT platform for further monitoring. Okay, the end, the monitoring process ends and the system returns to the initial stage to begin the next round of monitoring. Okay, this is the flow diagram for notification testing with the Blink application. Okay, next into the wiring diagram. The next step after determining the system operation through a flowchart is designing the electrical weighting schematics. This process begins with selecting the sensor to monitor water quality and acidity in the Carassius Auratus fish farming system. The system uses various sensors, including a pH sensor, a salinity sensor, a dissolved oxygen or DO sensor, a temperature sensor, and oxidation reduction potential or ORP sensor, all of which are connected to specific pins on the microcontroller. Additionally, an RS232 module is integrated for communication between the microcontroller and the HMI or IoT. For actuator control, a four-channel relay module is employed to manage devices such as pumps and the actuators too. With the fan and solenoid valve used to regulate water quality and temperature, the system also included indicator lamps and a buzzer for status notifications, like an alerts when water parameters are outside the desired range. To ensure proper operation, can supporting the components that require higher energy using a battery. With this setup, the system can collect real-time data, transmit it for monitoring, and automatically adjust conditions to maintain an optimal environment for the fish. Okay, here are the reference. I use 42 journals. And there is an inference fuzzy table. Lastly, I have and I make inference fuzzy logic in spreadsheet. You can search and you can view it in my test. Okay, that's all. Thank you for listening. Goodbye and wassalamualaikum warahmatullahi wabarakatuh.